So this is part 3 of chapter 5. This is the total sales in this thing right now. Look at the declaration of days, double for sales, and total sales as the accumulator. This is important. Anytime when you actually want to add things, you have to have a base to add things to. Now, we call that the accumulator in this thing with it. So you create your scanner object, which is the keyboard. You pass it in. You store it in as a keyboard. And this keyboard stores in the days. Your total sales, this total sales is the accumulator. It needs to be initialized at 0. Is the accumulator. If you don't have a base to add to, it's going to be very, very, very difficult in this thing. So what this does is it stores the total sales in here. This is the sales, and it stores the total sales by adding to the sales that add to the total sales. So technically, if I really look at this expression right here, this is, let me add in some lines in here. This is basically saying total sales, case S, equal to total sales plus sales. Alright, so this is the same expression, basically what I just wrote here. So this sales is this sales. Guess what this one starts out as? 0. So 0, this 0 is this 0. Okay, so this 0 is the 0. Add to the current value, it updates this total sale. And then this loop comes around the number of days with it, so you can take count. Remember now, you take the count, and it'll tell you the number of days until the count, you increment the count as well with it. So the key thing, how you increment and you update the days are very important. By the end of the day with this thing, when you have system print format in this thing, you're going to set this thing to 2 positions over, which is the 100th position, 10th, 100th, and cent of the total sales in there. All right. So this total sale is this total sale. All right. Very, 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 very practical, showing accumulation. Another way to show accumulation is anytime if you have, like, let's say if I ask you to create containers to measure the amount of rain in the 12 months, for example. So each of the month that you have, you start out, you have 0 basically with it. So you got to do January, you have to initialize it to 0, February 0, and then from that point on, you add accumulation or rainfall into those containers with it. Okay, so that's what that's about with it. Next, I want to talk to you about the Sentinel value, and this is going to be a test question that I'm going to ask you. So the definition for a Sentinel value, you got to know this one. So it's going to be in some sort of format, multiple choice. I'm going to leave it blank. Blank value can be used to notify the program to stop acquiring input. Yeah. So something along that line that not that exact word, but I'm going to ask you something along the line. Let's say a blank is a value that signals the end of a list that values has been reached, for example. Okay. So a Sentinel value is a value that tells at the end of the value that has been reached with it. So that's important for you to actually have. So when you're reading things in to process, if there's a user input, so you can prompt the user to basically, you can make up something fictional like -1. All right. Normally it would be a positive number. So a Sentinel is like the end of file record with this, and you can actually pull something up with this. And of course, it's in your soccer.point file with it as well. Let me pull that. So here is the soccer point.java file that's in your book. If you look at this right here, all right. This is what's called Sentinel value. Well, points can never be negative with it, right? But this flags it until you input. And if you want to exit the while loop, you put in a -1. So you will look at, if you plug in points right here, and if you plug in a -1 not equal to -1, that's a false, right? So the way how I want you to look at it, just imagine that -1 equal -1. That's a true, correct? And then the moment you put a negation in front of it, so it's a false. So once you put in a -1 is enter, this whole thing is skipped. You do not do anything in this curly brackets with it. So that's why they call that a Sentinel value with it. That's all this is about with it. Okay. So that's the soccer one with it. Nested loops are very important with it. When we actually look at how things are outputted. So the first iteration, it has to be true, and then it goes inside the iteration. What you're going to find out, these loops are going to be writing. So these are the if you kind of imagine, this is kind of like row, and this is kind of like the column. All right. So it tells you that the outer for loop, that's kind of like the number of rows that you have, and this is the inner loop, will be kind of like the columns that you can go dictate your number of loops with it. The example in the book is the clock.java. Give me a second. So I had to drop the font size down so we can actually see what's going on here with it. But here's the for loop. Remember now, you're dealing with is the new decimal format requires you to have the library file decimal format in this at the same time. So you use the FMT, that's your object that you're creating with this thing, and you look at this particular nested loops. There's nesting of loops in this. The outer one is going to be the hours. The next loop is going to be the minutes, and then the one inside of that, that's going to be the seconds. All right. So you can see how this output in this, and they set each of the parameter how you can actually write the format to each one of these things. So you basically write from the inside, from the right to the left, basically, in this particular column that's written in this thing, right? So that's the for loop that you see that's happening in this right now. Now, if any one of these things, like inside of these seconds, if it's false, it's going to kick out here. It's going to come out here and look at this one that's false, and it will kick out, and this one is going to be false as well. So again, this is designing to write kind of like a clock setting with this. Let me move on to the break statement in this thing. So anywhere that you see a case in a case switch statement, you can hard code a break statement there to stop things. If you recall, in a case switch statement, you have your case and your switch statement, your switch and your case statement, and if you put a break colon in there, that would actually allow you to stop. If you didn't have that break statement in there, that would actually drop down to the next line. The other one is the continue statement, which will cause the currently executed iteration of a loop to terminate, and the next iteration will begin with it. So you're going to see both of these. They're a left hand and the right hand, you can see. So take a look at when and what do you decide to use. So you decide to use a while loop. First of all, it's a pretest loop. Use it where you do not want the statement to execute if the condition is false in the beginning. That's when you use the while loop. Or another way of looking at it, if you know how many iterations there are, use a while loop. The second one is the do while loop. This is the only post-test structure. Use it where you want the statement to execute at least one time. All right. So in the do while loop, do this and then it tests. The for loop is another format of a while loop with it. It's also a pretest. Use it where there is some type of counting variable that can be evaluated to this. All right. So you got three structures in this thing that to look at with it. So it's they're repetitions with it, and they use it certain ways with it. In either way that you use it, whether it is a while loop or a do while loop with us in this next lab that you're going to see, or the lab that you're currently doing with it, I ask you to roll 10,000 rolls for the dice, and do one that is a post-test and do one that is a pre-test. You should get the same results, is my point. Okay? Let me stop right here for this third segment, and I'm going to cut this right now before we begin the next one.